Let's see, error detection. Let's start the session with the outcome. In today's session, we have 4 outcomes. Upon the completion of the session, the learner will be able to: outcome number 1, understand transmission errors. Outcome number 2, we will know the types of errors. Outcome number 3, we will understand error detection and error correction process. And the last outcome, we will know the various error detection techniques. Let's start the session with what is an error. In a computer network, obviously, data are transmitted in the network. When the data are transmitted over the network, we don't know what happens to the data once the data has left the node. So the data can be corrupted during transmission. So the errors that are caused because of this transmission are called as transmission error. And for reliable communication, these errors must be detected and corrected. In which layer the error-related things are handled? Actually, in OSI reference model, there are 2 layers that deal with error control. Error detection and correction are implemented either at the data link layer or the transport layer of the OSI model. Just recollect the OSI reference model and the services offered by each layer. In data link layer as well as in the transport layer, we have error control as one of the services of those layers. Now let's see what are the types of errors. We have basically 2 types of error. Number 1, bit error, and number 2, burst error. We will start with what is a bit error. In a bit error, only one bit is going to be changed. So it is also known as single bit error. And in a single bit error, only one bit in the data unit has been changed. We will understand this with this example. In this scenario, this is the sender side and let this be the receiver side. And the sender is sending 00000010. But upon reception, the receiver is receiving 00001010. If you notice here, this bit has been changed as 1. We can notice here the sender is sending some information, but the receiver is receiving a different information, and there is a change in exactly 1 bit. When there is only 1 bit change, we will call it as a bit error. Whereas if there are group of bits that are changed, then we will call it as a burst error. Let's see burst error now. In burst error, 2 or more bits in the data units have been changed. Let's see. Suppose if this is the information that the sender is sending and this is what the receiver is receiving, we can notice that there are some bits that are corrupted. The sender has sent 0 here, but the receiver is receiving 1 here. And this 0 here, but the receiver is receiving 1 here. And these 2 bits are also changed. Now when we calculate the length of the corrupted bits, it is not 1, 2, 3 and 4. The length of the burst error is 8 bits because this is what the entire length of the corrupted bits. It is 1, 2, 3, 4, 5, 6, 7, 8 bits. So far we have seen what is an error and the types of error. Now let's see how to detect these errors. Generally, error detection will be done by the receiver. It means the receiver has to decide whether the received data is correct or not without having a copy of the original message. The receiver normally will not be having original message because the original message itself has been corrupted by transmission errors. Now how to detect these errors? When we send only original message, it's very difficult for the receiver to understand or to know whether there is an error or not. So with the message, some additional information have to be sent by the sender so that these additional information will help the receiver to understand or to find out whether there is an error or not in the data that is being transmitted. So to detect or correct errors, we need to send some extra bits with the data. And these extra bits are called as redundant bits. Let's see what is redundant bits, that is redundancy now. In redundancy, suppose if this is the sender side, if this is the receiver side, if sender has this data to be sent, the sender gives the data to the generating function or an algorithm, and this algorithm generates a code which we call as the redundant code or redundant bits or redundancy check. And this information is appended with the message that has to be sent. And this is the message which is here. And this redundancy check or the redundant bits are added with the message. Added means just appended. And the whole information is now sent to the receiver. The receiver message, 2 parts in the message. One is the original message and the other one is the redundant bits. So he takes this original message and the checking function in the receiver side, this is also an algorithm. It calculates the redundant bits. It compares the redundant bits with the redundant bits that was sent by the sender. If both are matching, then the receiver understands that there are no errors in the transmission, so it accepts it. Otherwise, the receiver rejects this. So far we have seen how to detect errors. Now let's see error correction briefly. Error detection means it's the job of the receiver to detect the error. If it is there, it will discard it. Otherwise, it will accept it. Error detection is very simple. Just accept or reject. Whereas error correction is a tedious job. The receiver has to correct the errors. It can be handled in two ways. Number one, the receiver can have the sender retransmit the entire data unit. If the receiver detects the error, it can ask the sender to retransmit the entire information. Or the receiver can use an error correcting code which automatically corrects certain errors. But when we talk about error detection and error correction is normally a simple task, but error correction is somewhat difficult. Now let's see whether error detection and error correction needs redundancy. Yes, both error detection and error correction needs redundancy. Why? Because without additional information, it's very difficult to detect or correct the errors. So when the sender sends the data or the message, there will be a generator or some algorithm to generate the redundancy, and this redundant information and the message are generally sent over an unreliable transmission medium. We are saying it as an unreliable medium because it is prone to errors, and the receiver receives this information. Whatever the receiver receives, it gives that information to the checker, and this checker says whether to accept the data or reject the data, or whether to correct the data or discard the data. Correcting means this checker part tells which part is affected with errors and it can be corrected. Discarding means simply discarding the packet, and we can ask the sender to retransmit, and the message is finally received by the receiver. In today's lecture, we are focusing only on error detection. And what are the various ways to do error detection? There are basically 4 ways, 4 types of redundancy checks or techniques that are used in data communications, and they are: number 1, vertical redundancy check, which is simply called as VRC. Number 2, longitudinal redundancy check, simply LRC. Number 3, checksum or internet checksum or arithmetic checksum. And the last one is cyclic redundancy check, which is CRC. In the previous lectures, we have seen some protocols in the data link layer which uses error detection techniques. Some protocol uses CRC and some protocol uses checksum. These two are very familiar in protocols. And that's it, guys. I hope now you understood transmission errors. Now you know the types of errors, bit errors and burst errors, and you understand the difference between error detection and error correction, and know the various error detection techniques: VRC, LRC, checksum and CRC. I hope you guys have enjoyed the lecture, and thank you for watching.